Hello, welcome to today's webinar. The topic today is Consider Construction Stages in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, the German and English webinars, customer projects, etc. I will be the moderator today. My colleague Adrian will be the presenter, but he can introduce himself.
Yeah, hello. My name is Adrian. I'm responsible in our company for customer support, especially regarding questions about concrete design, but I'm also responsible for development and for testing, and in RFEM 6, especially for the construction status analysis. And yeah, this is also the reason why I would like to show you today the construction stages in RFEM 6.
Yes, he is our expert for construction stages. Okay, then we can switch off our webcam that the attendees can see the full screen. You can ask questions via the control panel on the right side of your screen. You can enter a short question here and I will answer you. If there are too many questions during the webinar and you won't get an answer, you will get an answer after the webinar via email. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, at first, Adrian will define the construction stages on the model. Then on the load side, he will do a design of the steel and concrete structure, and he will review the results. Okay, then I hand over the screen to Adrian. Okay, Adrian, it's your turn.
So you should see my screen now.
Yes.
Hopefully. Yeah. So then I will start. Today I will show the construction stages analysis with a simple fictive example. In this example, two concrete columns, these two, should be removed, and additional steel construction should be added. Possible background here could be a widening of the entrance here, or the passage through the construction. In the beginning, we have here the concrete structure already modeled, and also the design is already available for this original situation. So I can show here maybe the required reinforcement. So there are results for the, I changed the last time, I changed it here. You see the required reinforcement, and there's also defined a provided reinforcement, and for the situation in the beginning, there is no covered reinforcement open, so no not covered reinforcement open. So the not covered reinforcement is of course 0 for the original situation. Maybe some other information regarding the structure. The structure is consists here of these two slabs. Maybe I can switch off the results. These two slabs, and the columns or cantilever columns here, 7 meter high, with a square cross section with 30 centimeter high side, and the slab is also 30 centimeter high. As I said, the reinforcement is already defined, and I will start in the beginning with adding the steel construction. The definition about which part of the structure is active is later defined in the construction stages. But, and it's important, first all structural elements which should be used later in the construction stages has to be modeled in RFEM. So that's the reason why I start with modeling the steel construction. So yeah, because I do not know in the beginning how exactly my steel construction will work or will look like. I start with some kind of an approach. I will define a steel column here with cross section HEA 200 in the beginning. So I start here copying from the old columns the position to the new position here 1.5 meter away, and create the steel columns. As I said before, I'm not sure if it will work, but I have to start with some cross section. So I choose here the HEA 200 and create the column here. Of course, the results have to be deleted from the existing structure and here. And I also would like to apply steel girders here at the edge of the slab here, 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 and here. I can define them by editing the lines also. And in the beginning, I also start with the same section as for the columns, like this. I also add some hinges, but before I adapt the nodal support here, because it's not completely fixed, it should be hinged, and I choose here the common standard default nodal support at the bottom, and then I will add member hinges at the end of the columns, and I also use this the default member hinges here, which are hinged in for MY and MZ here, and the same in the beginning of the girder or of the girders and at the end. So here the same, and the same also at the end. And then I also have to add an eccentricity to the girder, because the steel girder should be applied below the existing concrete plate. So I will add an eccentricity here for these members. I have to check here the eccentricity, and I have to create an eccentricity, and it should be the alignment on top of the section and related to the surface bottom, and I choose this as the reference surface, and then I say OK and OK, and I forgot to choose it at the member end also. So I have to choose it here also. Yeah, and this should be the eccentricity for the girder at the bottom side from the surface. And I also will add an eccentricity to the column at the end of the column. here, and I have to create a new one. One moment, at the end. And this time it should be related to the bottom side of this member. Yeah, like this. So this should be okay for the eccentricities. Since the steel girders are applied afterwards for the existing structure and below the concrete slab, I would like to assume that not all forces are transferred from the slab to the girder. And to consider this, I also will add line hinge to these lines here at the edge. And this line hinge should only transfer vertical forces in positive z direction or in direction to the ground. I insert the line hinges here. There are different ways how to make an input. I choose here, for example, this possibility. And I say, okay, everything should be hinged or free, but for the z direction, I would like to consider the connection fixed if positive Vz or Vz forces are acting. And I, after I have defined the line hinge, I have to apply it to the lines. I first have to choose the surface and then the lines. Okay. And now there should be an line hinge here. This is by the way a new feature in RFEM 6 that it is possible to use nonlinear line hinges. And it is also new in RFEM 6 that this could be considered in the construction stages analysis. In RFEM 5, this was not possible. It was not possible to use line hinges in stages. And it was also not possible to have the nonlinearities there. This should be ready now. I also, due to the fact that it is an existing structure, there is also above the columns an existing mesh refinement and an existing surface result adjustment, or in RFEM 5 it was called smoothing region. And to avoid later some singularity effects, I can also copy the FE mesh refinement to this column, to the new steel column, and also the surface result adjustment. I can choose the FE mesh graphically and also could copy it graphically while pushing the control button and here, and drag and drop it to the new column. The same for the surface result adjustments. Okay, here. Yeah, and then this is ready for the input of the construction stages. So I will start now with doing the input of the construction stages. Before I have to activate the add-on construction stages analysis, and I also will activate the steel design because I later needed to design the steel construction. Okay. Yeah, the input for the construction stages works as following. There are two, let's say, important components for the input. There's the structure side, where I have to define which part of the structure is active in the single construction stages. And the other one is the definition of the load side, where I have to define which load is acting in which construction stage. I will start with the structure side. I can here create a new construction stage, and then I get the dialog for the for the definition of the construction stages on the structure side. First of all, I can create the number of construction stages I need. In this example, would be maybe possible to do to simulate this construction process with 2 construction stages, but to make it more clearly and understandable, I will choose 3. And in the first one, there is I can rename it here, there is the original structure. In the second one, there should be added the steel construction. And in the last one, there should be removed the concrete columns. Oh, let's say concrete columns. So, it would, from the theoretical point of view, it would be also possible to this 2 steps, or to summarize these 2 steps in one, but to make it more clear, I will use 3 construction stages. After creating the construction stages, I can choose which elements are active in the construction stages, but before I can choose which dialogues should be active, or which kind of structural elements I will add or modify. So for example, in the first construction stage, that's the original structure, there is active the surfaces, the columns, so the members, and the nodal supports. So I will activate members, surfaces, and nodal supports. And then I have to choose here, or I have to add the members which should be considered. So I will add these 2, these 3, these 2, and these 3 columns, and this one. And for the surface, it's quite similar. I have to add here this one and this one. Okay. And for the nodal supports, it works the same. I have to choose here the nodal supports which are active. There are also possibilities to modify an existing element. This will not be part of today's example, but you could, for example, change the member hinges of a member, or you have different properties to modify. And you are also able to deactivate elements which will be shown then in construction stage number 3. This is the first stage. The second stage, there I will add members and also nodal supports and the line hinges. Here it would be theoretical now possible that I don't have to select the members in the graphic. I also could use this button all, because there are no more members. So I could theoretically use this button, but I also could choose it graphically and check maybe the input here. Then I have here the information about what elements are added. The same for the nodal supports. these two are new in this construction stages. And the line hinges, for the line hinges, that would really be a possibility to use here the all button, because there are no active line hinges till this construction stage. So I have a good overview here about what line hinges are new. So this means it's related to surface one and then the single line numbers. Yeah, and the last construction stage would be removing the two active concrete columns. Should be these two. Yeah, maybe some other detail. If you once have activated an element, or if you once deactivate an element, you could not deactivate it again in a later construction stage. So here, for example, these elements are still active, so it would of course make no sense to activate them here again, because they are still active. Then you will get here such a small such a sign here that this is not possible. Yeah, this is the input for the structure side. If I leave this dialog with OK, I can here see now that beside the load cases and combinations, there are new elements here, the construction stages. These three which I've created, and I can check here graphically again how my structure in the single construction stages look like. Yeah. After the definition of the structure side, I can define the load side. I can, for example, open here. So if you have once created a construction stage here, you will also get the construction stage in the load cases and combinations here, and can open it in the navigator. Here, you are also able to open it directly here, like quite similar to a load case or a load combination, and can here, if you choose it here, and then you can directly edit the load side or the settings regarding the load side and regarding the combinations. So maybe some short explanation regarding this main register here and regarding the type of analysis. We have here two different types. Type load combination, which means it's possible also to calculate nonlinear structures. And there's the option to calculate linear structures or do a linear superposition. At the moment, in current state of development, we only have this nonlinear method, the method based on load combinations. Our example here, this is it is necessary to use the load combinations because at the moment we have nonlinear line hinges in our structure, so a linear superposition would be not okay for such a structure. Yeah, the other option, especially regarding the combination result, I will explain afterwards. Now I would like to show how to assign the load cases to the construction stages. You have here the register load case or load cases, and here you could assign the load cases. Maybe a short explanation because I forgot it. We have here, that's quite, let's say quite simple. We have a load case self weight with automatic determined self weight of the structure. We have some dead loads, and we have some live load. It's quite simple. And now I choose for the original structure. Everything should be considered: the permanent load, the self-weight and dead load, and the temporary load. This is here load case 3, the live load. And if I once have selected or assigned the permanent loads here, so load case 1 and 2, they are active in all following load cases. So they are here active. The live load, if the live load should be considered in the single construction stages, it has to be selected again. So here for construction stage 2, I will not add the live load. Maybe this is the view or the selection is a little bit misunderstanding. Here's a filter to show only the load cases of the current construction stage. So in construction stage 2, only the activated dead loads or the self-weight is active. And if I use a load case self-weight, which includes here the automatically determination of the self-weight, the program automatically recognizes that there is a steel construction added in this construction stage, and that there is applied new self-weight loads to this construction stage. Theoretically, it is also possible in RFEM 6 now, or in the construction stages in RFEM 6 now, to have empty load cases. This was not possible in RFEM 5. And to calculate empty load cases in the construction stages allows you to just adapt or just change something on the structure side, like a hinge or a support condition or something like this, without adding new loads, but the program is able to consider this. Here in construction stage 2, I will not assign other loads. In construction stage 3, that this should be our, let's say, final new structure, I have to add the live load again. With adding the live load, it is then also possible or useful to do the combinations again. The combinations I will explain now. In our origin structure, there was the automatic generation of the combinations active. Here, this combination wizard, and with activation of construction stages, I also would like to use this automatic combinations for the construction stages. To use this automatic for the construction stages, I have to activate it. So I have to activate here that there are combinations created according to the combination wizard for the design checks or for the design then. So I have to think, or I can think about where I need such combinations. So I would like to have the design for the origin structure, and I would like to have the design and the combinations for the construction stage 3 for the new final structure. So I will activate here the combination wizard, and I have to do a small adaptation. I have to choose for the combination wizard that construction stages should be considered. So I do here the check, and then for construction stage 3, I also will activate the combination wizard, and here it is already, because it's the same wizard which is used. here it is already active. The program should then generate the action combinations and the load combinations automatically for the construction stages, and this is what we see here. We have now two different action combinations for construction stage 1, and the same action combinations also for construction stage number 3. If I then change to load combinations, the load combinations are also generated automatically. And I see here, according to the action combinations, the two different combinations for construction stage 1 and for construction stage 3. And there's also another combination generated, which is some kind of an auxiliary combination, which is needed to have this step between construction stage 1 and construction stage 3 with the factorized permanent loads. So if I take a closer look here, for example, to combination 1, I see here it's related to construction stage 1. And here I see the special options, which are here just for information, as long as I use the automatic. If you do this manually, if you create manually load combinations, you have to choose here for the special option which construction stage should be considered and which initial stage should be considered. But for the automatic, everything is done automatically. So for the first combination, we have here, for example, the construction stage 1 on the structure side. And if I switch then to, let's say, combination 3, that is construction stage 3, then there's on the structure side considered construction stage 3, and as an initial state, there's considered this combination 5, this auxiliary combination, which considers the construction stage 2 with the permanent load. So it's like, if I do it step by step, this would be the first one to calculate. Then the combination 5 would be the second one with initial state from combination 1 and considering construction stage 2. And then afterwards, the combination 3 is calculated with initial state combination 5 from combination 5 and considering construction stage 3. So it's like, step by step. And it's also, if I start then the calculation, you will see that if I, for example, start with combination to calculate combination 3, the program recognizes that there are no results available, so it has to be, or it calculates first combination 1 and combination 5. I guess we are ready with the definition of the combinations, so I can show it. So if I now, for example, start with combination 3, which is related to construction stage 3, the calculation should be first done for combination 1 and 5. So we will see if it works. First of all, the mesh has to be generated. And here, as here you see, it starts because there are no results available, and the results are based on each other. So this is construction stage 1, 2, and this is 3. But with the consideration of the factorized loads. So this is should be the generation of the combinations. Of course, the auxiliary combination here is only needed to calculate the combination step by step. For design of construction stage 1 and construction stage 2, we only need these combinations here. Okay, then I can start with the design of the structure, and I will start with the steel design. I already have activated the steel design, and before the design, I will adapt the ultimate configuration, or I will add another ultimate configuration. So I would like to create one ultimate configuration for the girders, which are, one moment, I have here and here, and I will deactivate the stability analysis for these girders, and for the columns I have a known ultimate configuration with active stability design. Of course, I can rename it here also girders columns. So okay, and for the columns, before I start the design, I also have to define an effective length. So I will edit the members again, and here for design type, I have to choose an effective length for the stability analysis. So I will create a new one, and I use the default values. So it is effective length factor 1.0. So it's the same like the length of the column. Okay, yeah, this looks good. Yeah. So yeah, this is all which I have to do here for this example for the input of the steel design. So I can do the calculation for the steel design, and when calculating the steel design, of course, all other combinations which are not calculated until now will be calculated. Should be combination 2 and 4, I guess. One moment, I forgot something. I would like to choose only the steel members, because otherwise I get the message that the other members are not able to design in the steel design because they are not made of steel. So, but I can only choose the steel members. This should be okay. And then I will start the design. And then we will have a look if it is okay. Yeah, exactly. The combination 2 and 4 was not calculated until now. We also see that it is a nonlinear calculation. Yeah, no. And the steel construction looks okay. The results are here shown for construction stage 3 and 1, because I have chosen design combinations and design situations for the construction stage 1 and 3. Of course, it is the results are here 0 for construction stage 1, because there is no active steel member in construction stage 1. In construction stage 1, there were only concrete elements. Yeah. So from the steel design looks okay. Then I can go on with the concrete design, and I can start the calculation. The input for the concrete design is already done, because it was done for the original structure. So I have to, I don't have to do any input here. And I can have a look how the results will look like. Maybe I start here with the construction stage 1. This is what was our original structure, and it should be the same results like in the original structure without construction stages. But I will check it. Here is the not covered reinforcement should be nearly or should be exactly everything everywhere 0. Yeah, and it is the case. So this should be the same like in the beginning, our concrete design, but new, the results for the construction stage 3, this is a new situation. They should be new, and I could now here check with adding the steel structure. I can check the reinforcement, and this is the not covered reinforcement. So this is the difference between required and provided reinforcement. So this is a reinforcement which is additionally needed. So if I here take a look at the column, at the new steel column, I see that above this column in the first reinforcement direction, I get there's an additional reinforcement needed. But of course it was, or it is an existing structure. I am not able to apply additional reinforcement. I could not change this existing situation. So I know here in this example, this kind of construction would not be a solution or would not work. So now I have to think about, or yeah, I have to look for another solution. There are probably quite different solutions how to adapt this structure. I will here only show one, yeah, let's say theoretical possibility to show how it is possible to adapt now such a structure, including the construction stages. Yeah, I see here that the problem is the moment above the support, which causes this required reinforcement on the top side. So it probably will not work to have this steel girder below this concrete slab. So maybe I can apply this steel girder different, maybe in the plane of the concrete slab, and maybe that it is that it edges the concrete slab. So I can show it. So I have to change the cross section of the steel girder. So I have here, for example, it was it's already prepared welded cross section, which got exactly the height of the thickness of the concrete slab. So it is here 30 centimeter, and I can change here the cross section, and I could change the position, or I could remove the eccentricity here, so that it is possible that the steel section will be able to edge the slab here. In in reality, it maybe has to be checked if this is a practicable solution. But here, from the statistical point of view, it would be an idea to do it like this, to have here a steel girder which is also able to cover this moment about the support. And it is just for showing what are the, or how it is possible to change the structure here in combination with the construction stages. Due to the fact that I did not change any number of the member or everything else, I only have to recalculate the internal forces and the design. I also could directly start with the design because the program should automate. And I just remember I forgot anything. I forgot something. Due to the fact that it is that the steel girder is not below the slab anymore, I could also remove the line hinges. I can do it directly here in the navigator, or I can select them. There are also the different possibilities. So I can remove the, and I can do the, or can calculate the design again, and the program of course should automatically calculate the whole construction stages again. And then we will see if it works for the steel design. And it probably will work for the steel design because it worked also before for this smaller section. Yeah, it works here. It would be maybe also an option to not use a I section here. It would be maybe a possibility to use a U section or two connected U sections here in the area of the surface, on the area of the column here. There are probably different possibilities. That's just one, let's say, idea how this could be adapted. So the steel design still works, and I will check if the concrete design has changed, and it probably will change because there's some, there's a different situation now for this area here, for the connected steel column here. And we can then, after the calculation is finished, check the results again. It's the same. Construction stage 1 should be not different because there was nothing changed. It's only about construction stage 3. And if I have now a look at the not covered reinforcement, there was before something like 11 square centimeters a meter, as I remember. It is now much smaller. It is not completely zero, but it will probably work. So this would be okay here, and I guess in the other direction there's only also only a small value. Could be, I'm sure, but could be also influenced by some singularity effect. And here is also not a quite large value. So this of not covered reinforcement. So this solution looks much better than the solution before. This would probably work here, and it was just to show what possibilities you got regarding the stages calculation. And this should be all with this let's say small example. I was trying to give you a short overview about the construction stages analysis in RFEM 6 and some of its possibilities. Of course, there are much more possibilities. We have, for example, already made an older webinar on RFEM6 in combination with construction stages, where there was shown an example with a build-up multi-story building. So with as I remember, it was 20 stories. Of course, this is also a typical situation for the construction stages analysis. Yeah, and this older webinar you will also find on our homepage. Yeah, and there are much more, I guess, examples to show where the construction stages would be quite useful. So yeah, this should be everything from my side. Yeah.
Okay, Adrian, thank you for this presentation. Yeah, you mentioned it. Yeah, we record all our webinars. You can find the first webinar of construction stages analysis in RFEM6 and today's webinar on our website. You can use the showed models in these webinars. Let me show you how to find such webinars. Just a moment. For example, today's webinar, you can find it under on dlubal.com. That's our website. Then here in the middle, news and events, you can find the webinars. For example, today's webinar, or if you enter a word here, stages, for example, then you will find also the webinar from January. Yeah, you can see that structure here. That's today's webinar. If you click on it, you will find the recording here in the middle. In the next days, you can find the presentation slides and important, the model here. Okay, yeah, if you want to try something out with the model and the webinar recording, you can use RFEM6 if you have already got the add-on construction stages analysis. But you can also try it with the free trial version. Here above, you can find a link. And then you can download our trial version of RFEM6, for example. You can try it for 90 days with all add-ons. Or if you already use RFEM6 and you haven't got the add-on construction stages analysis, then just contact us and we will release a trial for a certain time for that add-on. Okay, that's also all from my side. I thank you for your attention. Thank you, Adrian, for this nice presentation. Maybe a short information when you close the webinar, there's a small survey. Would be very nice if you answer some questions. If you score the webinar, it takes maybe only 1 minute. Just note that the worst score is 1 and the best score is 5. It's quite important to mention. Okay, that's all. I wish you a nice rest of the day and bye-bye.
Yeah, bye also from my side. Thank you.